In this video, I'm going to demonstrate programming a simple protocol just to perform a mix on this drop. And so the first thing that we'll cover here is that we can operate in real-time mode. So when we're operating in real-time mode, we make sure that this checkbox is enabled, and we can see the voltage is being updated in real time, and that's according to whatever step we have selected here. So if we've adjusted the voltage parameter here, this will try to match that, and so that will be changed in real time. So for instance, if I type in 100 and press enter, then now the voltage that is being applied by the dropbot will be adjusted accordingly. And so that's the voltage that's being generated. Then the electrodes to which that voltage is being applied are selected based on which electrodes are selected and highlighted on the device interface. So if we click now on one of these electrodes where I've got liquid covering, then the liquid will be attracted to those locations on the chip. In this example, I'm using propylene glycol dyed with green food coloring just to make it a bit easier to see the liquid. If real-time mode is enabled, it makes it easy for us to move a droplet around if we use the directional keys in the device user interface. So to use the directional keys, you make sure that this window is selected, the user interface window for the device, and then you hold the control key on your keyboard and use the arrow keys to move in the direction that you'd like. So up, left, down, right, for example. And the way that this works is if you have multiple electrodes selected, it will turn on the corresponding neighboring electrode for all of the selected electrodes. Now, let's say we wanted to perform a mix operation. So if we brought out two drops and we wanted to mix them together, one way to do this is to draw a route. So if we click and hold our mouse, then we can draw a path for that drop to follow. And if we want to repeat the same pattern to for example, perform a mix, then we would want to end up back where we started. And this type of route is a cycle. For any cycles on a step, you can then select the number of times that you'd like that cycle to repeat. In addition, you can select how long you want each actuation to apply in sequence for the entire route. So for example, if we have it set to 1, it will turn on each actuation along that route for 1 second before proceeding to the next one. So let's watch that with just one repeat. I'm going to increase the voltage here just to speed things up a little bit. And we'll press play. So here you can see it's going to apply each actuation for 1 second until it reaches the start again. And if we are still just experimenting and in development, I would suggest not to start a new experiment. We'll talk more about what an experiment is in another video. So I'll just click no in this case. Now, one option, as I mentioned, was to specify a number of repeats. So if you just want to mix it for 100 loops, then that will cause the drop to move around 100 times before continuing on to the next step in the protocol. But let's change that back to 1. Another option is to repeat for a specified duration. So in this case, we can say repeat for let's say 30 seconds or 15 seconds. And then we'll press play. So you can watch the step time here. So we're at 3 seconds, 4 seconds. And what will happen is when it gets back to the start of the cycle, it will check to see whether or not that specified time has passed. If it hasn't, then it will complete another full cycle and then check again the next time it finishes. And this time it will stop. So you can easily do this to specify a mixing routine that goes on for, say, a minute or 5 minutes or something like that, very concisely, where you just specify the duration that you'd like to repeat. Now, that shows one mixing step, but then after that mixing step, we may want to move the drop somewhere else. So to do that, we can click the next button here, and that will automatically either, that will create a new step if one doesn't exist after the current step. If one does, then these buttons will just move to the previous and next steps and update the UI accordingly. The outer two buttons move to the last and the previous steps. Once you click on a step, the steps, or the properties and attributes of that step will be applied automatically. So in this case, we could change the voltage for the second step to 105, and because we're in real-time mode, you see that it immediately takes effect and the actuation voltage changes to 105. If we select the first step again, then those settings will be applied, and you can see that the voltage is then changed to 115. Now, again, if in the second step we may want to move the droplet, for example, to this position. So one way to do that is to click and drag, and we can select any path that we'd like to end up at that final destination. If we want to clear that route, we can right-click, select electrode, clear electrode routes, and that will clear any routes that pass through that electrode. Or we can say clear all routes, and that will clear all the routes on the current step. Another way to move up to that electrode is to hold the Alt key, click on the starting position, like I did here, and then just drag our mouse. It doesn't matter where you drag it in between, just as long as you end up on the electrode that you want to finish on, and then release the mouse button and the Alt key. And what will happen is it will automatically route a path between your current position and that ending electrode. That's just a nice shortcut if you want to move a large distance across the chip and don't want to have to explicitly drag a path there. So now we'll change the repeat duration back to 0 so that we will perform the specified number of repeats. In this case is just 1, so we'll do 1 cycle of this mix and then continue on to the next step. Now on this step there is no cycle, so the repeat duration has no effect, but I'll set it to 0 anyway. And we'll see here that we'll press play. We'll follow the path around, and once the cycle is complete, it will move on to step 2 automatically. And now we've reached the last step, so we'll ask if we want to start a new experiment. I'm again going to click no. Okay, now you may also want to set a step where you just explicitly actuate for a certain length of time. So let's say we want to turn on these electrodes and just bring the droplet here and leave it for a certain amount of time. Maybe it's some incubation time where you don't necessarily want to be mixing it actively, but you just want to have some time where it's sitting before the next step proceeds. The way that you can do that is just by changing the duration for that. Create a new step, so you can click the next. There are also shortcut keys that map to first, previous, next, and last, and that corresponds to A, S, D, and F. So you can press S and D to move back and forth between the previous and next steps. You can also use the arrow keys if you're selected in the main window. The S and D work even if you've got the device user interface selected. So that can be nice to use those shortcut keys. And so let's change the duration of this step to 4 seconds, for example. Now, if we play the protocol, it will start at whatever step we have selected. So because we've already got our drop over here, I'm going to just start it on this step, but the same thing would happen if we started it in sequence. So in this case, we'll press play, and it will execute, and this time will go up to 4 seconds, and then at which point the delay is complete for the specified duration, and the experiment will complete. Now, you may have a step where you don't know the exact duration, but you're waiting for something to happen. So to handle a situation like that, I'll create a new step, and in this case, you can set the duration to 0, and we can prompt the user to tell us when it's safe to proceed. So, for instance, we can put in this message column, we can put a question. It doesn't really matter what the question is, but this is just a prompt to the user to tell us that it's okay to proceed. So we may have some reaction that we're looking for manually, and we don't know exactly what time it will take during development, so we want to have an operator be able to specify when it's ready to proceed while we're tuning our durations. So to test this, I'm going to create one more step, and I am going to then try to take our drop back to its starting point. Okay, so in the last step, I'm going to draw a route that will bring us back to our starting point. And in this case, I want 1 second for each actuation, and I'm going to increase the voltage to just help make it move faster. And we'll start back at our 4 second duration. So it's going to wait on this step for 4 seconds, but on the next step, it will wait until we click ready. So if I click OK, then the next step will execute. It will take 1 second on each actuation, and now the protocol is complete. So in this way, you can see that we can perform mixes where we specify either a duration to mix for or a number of times to repeat the cycle, and that will repeat any cycle that's on the step. So that's a route that ends on its on the same starting point. We can also just program routes to make a drop follow that path. We can explicitly actuate electrodes for a certain amount of time using a duration. And we can also use prompts to allow an operator to specify when it is okay to proceed to the next step in the protocol. And once you've developed your protocol, then you can click Save and give it a name. So we'll call this Demo Mix or something like that. And when you launch MicroDrop the next time, it will automatically load the most recently used protocol.